Namaste children, namaste. A hearty welcome to all my beloved students. How are you children? You must have probably understood the very first chapter in 10th standard mathematics. Yes, it is arithmetic progression, AP. Okay, it is full of patterns, various patterns in number system. Okay, and I believe that you must have completed the assignments also given to you in this regard. Okay. Children, the earth on which we live, okay, the nature around us is so beautiful, colorful, amazing and diversified also. Okay. Look at the plants for some time, children. Okay, I will show you some leaves of the plants. Look at the first leaf, beautiful yellow color leaf, blue, green with yellow, and see this is another type of leaves you are seeing almost like a triangular shape, and now there is another green, deep green leaves with a yellow flower also. Don't you think it is so beautiful? The shapes are so beautiful, exciting, children. Okay. So, in triangular shapes, we have got isosceles triangle, equilateral triangle, and in quadrilaterals, we will have square, rectangle, rhombus, trapezium shapes also you can see in the leaves of the plants, and even in some regular polygons also, like regular pentagon, regular hexagon, and even you have seen just now a beautiful circular shapes also. Okay? Yes, and all these shapes, don't you think we have studied in your previous classes their definitions, properties, areas, constructions, and why don't you recall them, children, for some time. So, recall all these things which you have learned in your geometry classes. Okay? Fine. Now, I wanted to tell you one important main objective of learning geometry or studying geometry. Have you ever thought of this, children? So, the very important objective of studying geometry is this, children, to know about the shapes, to know about the areas. This is the main objective of studying geometry, children. In Kannada, we call this as akaragalu ಮತ್ತು ವಿಸ್ತೀರ್ಣಗಳು. ಇದನ್ನು ಅಧ್ಯಯನ ಮಾಡತಕ್ಕಂಥದ್ದೇ ರೇಖಾಗಣಿತದ ಒಂದು ಪ್ರಮುಖ ಉದ್ದೇಶವಾಗಿದೆ. ಓಕೆ ಚಿಲ್ಡ್ರನ್, ಐ ವಾಂಟೆಡ್ ಟು ಟೆಲ್ ಯು ವೆರಿ ಬ್ರೀಫ್ಲಿ ವಾಟ್ ಡು ಯು ಮೀನ್ ಬೈ ಶೇಪ್. Okay, so shape means it is nothing but the external form of something that we see or we feel. This is called the meaning of a shape. Okay, because we are going to talk about the shapes of triangles only in particular, and you already know the concept of area also. Area means, yes, it is the amount of surface contained within the boundary of a figure, children. These are the important terminologies which we will be using very frequently in this chapter. Okay. So, please make a note of this also. Okay. Now, I wanted to briefly tell you in this introductory session on chapter 2 called triangles, we are going to study the shapes, in particular triangular shapes only. Let us try to understand in this chapter, in this unit. So, in order to understand this, children, I would like to place it before you some 5 different varieties of situations which you have already learned from your previous classes. Are you ready, children, with the classwork, pen, instrument box? So, please make a note of them very carefully, neatly and systematically also. So, by trying to understand these things very sincerely, the 5 situations which I am going to tell you right now, we shall start today's lesson. Are you ready, children? Yes. Here we go, children. Yes. The first one is this, children. Look at this situation number 1. Here is a right angled triangle. We have seen this. Here is a right angled triangle ABC, in which angle ABC is equal to 90. The moment you see this, I think you will recall one important property. Okay, the side AC is called the hypotenuse, and you will say that AB square plus BC square is equal to CA square. See, this is the square on this side, this is the square on this side, this is our hypotenuse, and here is the square on this. So, area of this is equal to sum of the areas of these two. This is called, come on, tell me what is the name of this theorem? This is called Pythagoras theorem. Okay. One of the most important theorem, children, that we have to understand. Okay. So, how to prove this, children? This is the important objective of this particular chapter. Okay. We are going to discuss in this chapter, chapter number 2, called triangles. Now, let us go to the situation number 2. Here is a figure. What is this figure is called as? Yes, it is called a tumbler. It resembles a tumbler or a bucket. Okay. And technically, it is called as the frustum of a cone, and in this session, in this year, in fact, we are going to discuss the volume of this frustum of a cone, which is 1/3 pi h into r square plus rr, r and r being the radii of the bottom and the top, children. H is the height between the perpendicular distance between the two circular bases. Okay. You are going to understand this, work out many problems in the chapter number 15, and it is called surface area and volume. We are going to discuss the problems only, but not the derivation part. So, if you want to really understand this, you need to understand this chapter number 2. Now, here is another important third situation, children. Look at this, the 3 triangles. Look at the angles, children. In all the cases, it is 90 x, 90 minus x, correct? Can you observe that in all the 3 triangles, the angles are 90 degrees, x degrees and 90 minus x. And the side opposite to the right angle, you know that it is called hypotenuse. Let us denote each side of the right angle triangle as by lower cases P, Q, R in the first triangle, K, L, M in the second triangle, and U, V, W in the third triangle. No doubt, hypotenuse is the longest side, and say we wanted to compare how far the side denoted by P is smaller than R, how far K is smaller than R, and U is smaller than W. So, if you want to compare these two sides, what is that we need to do? We have to take the ratio between the sides like this, P divided by R. If you take the ratio like this, then you will come to know how far P is smaller than R. In the second right angle triangle also, you can take the ratio between K and M, so that you can compare the lengths of the two sides denoted by K and M, and L by W also. Can you make any guess, children, in this regard? P by R and K by M and U by W, and it is so surprising. You will see that all these 3 ratios will be equal, and say it is equal to a particular number called a constant, proportionality constant. Okay. Now, this in future we are going to call it as, this constant ratio is called as sin theta, or in this case sin x, which is equal to P by R, a constant, children. Okay. This is one of the important fundamental concept of trigonometry. Okay. So, how to understand this is the challenging question for you. How P by R and K by M, U by W, if the angles are equal, the ratio between P and R, K by M, U by W are equal to a constant. This you need to understand this. Okay. This we are going to share with you in chapter number 11 called trigonometry. Okay. Now, fourth situation is this. Oh, you have drawn this in your previous classes. Can you name this diagram? This diagram is called as ray diagram. Correct, children? Can you recall this? This is called a ray diagram. Okay. You know there is a beautiful formula connecting u, v and f, and you know 1 over u plus 1 over v is always equal to 1 over f. Okay. This is called mirror or lens formula. What is u, v, f, children? U is object distance, v is image distance, and f is the focal length. How to prove this is the challenging question for you. I wanted to give you some hint here. So, if you can happen to draw a perpendicular from D, say to the principal axis, say DE, I think some of you can think and work it out. The formula 1 over u plus 1 over v is equal to 1 over f. Now, the last situation number 5 is this, children. We have studied in 10th standard classes this particular year a series called arithmetic series, children. There are so many types of series like this. This is the first and the fundamental one. Okay. And Fibonacci series is also just one among them. Okay. So, here is a chart I wanted to show you called observe this chart, children. This is called Fibonacci gauge, okay, pantograph, okay, or a golden ratio gauge. Have you ever seen this kind of an instrument anywhere, children? Okay, thank you. Okay. Now, this is called by 3 different names: Fibonacci gauge, pantograph and golden ratio gauge. Do you know how this instrument, this gauge works, children? It is really fantastic. So, where do we find the satisfactory answers for all the 5 and many other similar such questions is our question for you. So, in order to answer all the above questions very successfully, which are from various chapters of previous years, we need to understand carefully certain basic concepts. For this, we need to refer one and only one particular chapter from 10th standard mathematics, that is the chapter number 2 called triangles. I think you were able to appreciate the beauty of the importance of this particular chapter called triangles. Without this, I do not think it is possible to understand the entire 10th standard textbook. So, all the concepts in this chapter are so important. Shall we start, children, with this preamble? Okay. So, chapter number 2, triangles, is a very fundamental and a very important chapter for you. For this, we have allotted 8 sessions are allotted for this, and this being the first session. Okay. Before we commence this chapter, children, here is a brief statistics of this chapter. It is worth to have a statistic something like this, where you will be seeing number 1, what are the concepts that we are going to understand, the number of worked examples or the problems, and the number of activities, etc. So, I am going to show you briefly a very important statistics for you. Here it is. For this, carefully observe the next slide. Look at this chart, children. The columns are concepts, number of worked examples, example number, exercise number and number of problems in it, number of activities, number of pages printed in the textbook. See, look at the concepts column, about 9 theorems are there with 14 worked examples and 6 exercises with 65 problems and 6 activities, children. For this, about 38 pages out of 402 from volume 1 and volume 2 are printed in our textbook. So, roughly say it works out to 10%. So, in the public examination also you can expect 10% of 80, which means 8 marks you can definitely expect for this chapter. Okay. So, please have statistics like this for each and every chapter, and also at the end of the chapter a note to the reader is given, 2 notes to the reader is given to you, you please go through that also. In other words, in this chapter there are about 79 problems. So, 14 worked examples and 65 problems. The purpose of showing you is this: for the public examination even the worked examples are also equally important. Please read them and study them, make a note of it in your class or book, children. And in the entire textbook the statistics is this: about 56 exercises are there, 168 problems with 582 exercise questions are there, children. Altogether it works out to be 750 problems. More the problem we work out, so more the clarity we have, do not think otherwise. It is a very, very small thing. Please bother to understand the entire textbook. Okay. Now, with this introduction, I am going to start the chapter called triangles. Look at this figure, children. Here are a pair of triangles A, B, C and triangle D, F. You can also draw this, take scale, pencil and neatly draw with the help of scale and pencil a pair of triangles like this. Once you draw this, take the protractor and measure the angles in both of them. Say in this case you can see that angle B is 60, unfortunately angle E is also 60, children. Okay. Now, let us come to angle C and F. In this case angle C is say somewhere around 30 degrees and angle F is also 30 degree. Therefore, angle C and angle F are equal and each equal to 30 degrees. So, 60 plus 30 is 90. We know sum of the 3 angles of a triangle is 180 degrees. Therefore, what should be the third angle, children? So, this is the symbol for 90 degrees. So, angle A is 90, angle D is also 90. Therefore, we write angle BAC is equal to angle EDF, which is equal to 90. Children, have you ever drawn a pair of triangles like this? Have you ever seen such a pair of triangles, these children? Okay. Or can you just tell me what is the name of this kind of a triangle? What is the name that you wanted to suggest? Yes, the 3 angles of this triangle ABC are equal to 3 angles of triangle DEF. Therefore, yes, you are right. It should be called as equiangular triangles. Equilateral is different. Equiangular means, this is the definition, here it is: if 3 angles of one triangle are equal to 3 angles of another triangle, it is simple, children, you should call it as them as equiangular triangles. So, this is the main fundamental concept of this chapter. So, please remember, equiangular triangles means the 3 angles of one triangle are respectively equal to 3 angles of another triangle. Then it is quite natural to say that they are equiangular triangle. In Kannada, we call it a sama koniya tribhujagalu. Correct, children? Okay, fine. Yes. Now, here is a pair of triangles. Observe their shapes of the pairs of the triangles that is coming up to you on your monitor screen. Do not you think they have the same shape, children? One is larger than the other, that is all. Okay, look at the other pair of right angle triangles. How it looks to you, children? They also seems to have the same shape. So, in geometry we call these triangles which are having the same shape, akara onde idre, children, we call them as similar triangles. Okay. Similar means the shapes of one triangle is the same as the shape of another triangle. So, that is the meaning of the similar triangle. In fact, this is the name of the chapter 2 also, called similar triangles. It is one of the fundamental important concept. Okay. So, let us try to define what are similar triangles in the next slide, children. Okay. Similar triangle definition. Okay. Can we state like this? So, we can define similar triangles as this way. These are the triangles having the same. Is it possible, children, to fill up this gap, children? When do you call two triangles as similar? Yes, you are right. They should have the same shape. Then only we can call them as similar. So, these are the triangles having the same shape, but not necessarily the same area. Area may be different, area may be the same. If area is same, then look at the thing that is coming up to you under note. If the areas are also same, then come on, tell me, recall 8th, 9th standard geometry classes. Yes, we call them as congruent triangles. Children, correct? Am I right? So, if the areas are also same, shape is same, area is also same, then we must call them as congruent triangles. If only the shapes are same, we must call them as similar triangles. So, similar triangles and congruent triangles are like two eyes for a person to see clearly the things around him. Okay. So, these are the figures are also coming up to you. Congruent triangles, look at them, they have got the same shape, they have got the same area. Such a pair of triangles are called as congruent triangles. Otherwise, if the shape is only same, it is called similar triangles. Okay. Now, here is a definition of congruent triangles also. I would like to define this way. If two triangles have point number 1 the same shape and point number 2 condition number 2 the same area, then we call them as, they are called as congruent triangles. Children, in Kannada we call it as so nicely, children, it is called sarva sama. ಸರ್ವ ವಿಧದಲ್ಲೂ ಸಮ ಆಗಿದ್ದರೆ ಏರಿಯಾನೂ ಒಂದೇ ಇದ್ದು ಶೇಪೂ ಒಂದೇ ಇದ್ದರೆ ಆವಾಗ ನೋಡಿ ಆ ಸರ್ವ ಸಮ ತ್ರಿಭುಜಗಳು ಅಂತ ಕರಿತೀವಿ, ಕಾಂಗ್ರುಯೆಂಟ್ ಟ್ರಯಾಂಗಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ ಮಕ್ಕಳೇ. ಸೊ ಕಾಂಗ್ರುಯೆಂಟ್ ಟ್ರಯಾಂಗಲ್ಸ್ ಸರ್ವ ಸಮ ತ್ರಿಭುಜಗಳು ಅಂತ ಕರಿತೀವಿ. ಓಕೆನಾ? Yes, congruent means identical in all respects. That is called the meaning of the word congruent. Here is a brief comparison between similar triangles versus congruent triangles. Okay. Look at study the shapes first, children. In both the cases, shapes are same. Okay, similar triangles, congruent triangles, they will have the same shape. Okay. In similar triangles, the areas may be different or areas may be same, but in congruent triangles they will have, both the triangles will have same area. Now, look at the symbol that we use to denote similarity and congruency. See, the sleeping S in between them should be read as similar to. Triangle ABC is similar to triangle DF. What about congruency, children? Congruency means 3 lines and then the top sleeping S. So, triangle ABC is congruent to, see, we are showing you the help of that cursor also. Please see that triangle ABC is congruent to triangle DF. Okay. Now, this is called in Kannada Samarupa. ಆಕಾರಗಳು ಒಂದೇ ಇದ್ದರೆ ಅದನ್ನು ರೂಪಗಳು ಒಂದೇ ಇದೆ ಅಂಥೇಳಿ ಸಮರೂಪ ತ್ರಿಭುಜಗಳು ಅಂತ ಕರಿತೀವಲ್ಲ ಮಕ್ಕಳೇ. ಇದಕ್ಕೆ ಸರ್ವ ವಿಧದಲ್ಲೂ ಸಮ ಆಗಿರೋದ್ರಿಂದ ಆಕಾರ ವಿಸ್ತೀರ್ಣ ಏನು ತೊಗೊಂಡ್ರು ಎಲ್ಲದರಲ್ಲೂ ಸೇಮ್ ಇರೋದ್ರಿಂದ ಎಷ್ಟು ಚೆನ್ನಾಗಿದೆ ಅಲ್ವಾ, ಸರ್ವಸಮ ತ್ರಿಭುಜಗಳು, ಕಾಂಗ್ರುಯೆಂಟ್ triangles. So beautiful, children. These concepts are so fundamental, children. You will understand future how beautiful they are, how important they are. Okay. I wanted to tell you briefly something about the symbol for congruency. What is the symbol for congruency? Equals, on the top of that sleeping S. Do you know what is the concept behind this symbol for congruency? It is this. So, that is the symbol for similarity. If you just write single sleeping S, we read it as similar, and this is, that is the sleeping S, and whereas this is the sign of equality. Okay. So, both these things are combined in the symbol congruency. If two triangles are equal in area, okay, then we must call them as congruent triangles. Hence this symbol. So, equality means if two triangles are equal in area, then they will have same shape as well as same area. Therefore, we write equal sign, and on the top of that we write the symbol for similarity, that is sleeping S also, and this is how I think the symbol for congruency must have been obtained or understood. Okay. So beautiful. So, equals plus similarity is equal to, that is nothing but the symbol for congruency. Okay. See, we have now recalled congruent triangles which are studied in 8th standard, and try to understand similar triangles. Before we go to the next important concept, children, we need to recall one more important concept, children, which is that another important concept is required to understand this chapter thoroughly, children. We are going to use very frequently in this chapter, and it is converse of a theorem, which is equally important for our future understanding. So, briefly I would like to recall what do you mean by converse of a theorem. In Kannada it is called as Viloma Prameya anta karitare. So, how do you define this, children, converse of a theorem? If data of a theorem is made to prove or hypothesis of a theorem is made conclusion, and the to prove part of the theorem is made data, then we call each statement as the converse of the other. Every theorem, whatever theorem you take, it will have two things: hypothesis, that is data, and whatever we want to conclude, that is called to prove. Just you interchange this. You make data as to prove as data, then you get another important statement, and that is called converse of the other statement. Okay. So, in geometry, if you do not understand, if you do not follow converse of a theorem, you are actually done with only 50% of the concept. So, please pay the importance for converse of a theorem also. Okay. Congruent triangles versus similar triangles, we are trying to understand this. So, congruent triangles, do not you think they are similar triangles only? If two triangles are congruent, shape will be same, area will be the same. So, we can say congruent triangles are nothing but similar triangles. Now, can you tell me what is the converse of this statement, children? Okay, this is a very important statement. What is the converse of this statement? And once you state the converse also, you should never stop there. You should always inspect whether the converse is true or false also, because there are many cases are there where converse is not at all true. So, we have to validate that also. Is the converse is true always? Can you tell me the converse of the statement? If two triangles are congruent, then they are called similar triangles. What is the converse of this? Yes, can you think for a while, children? Good, you are doing it. Yes. What is the converse of this? The converse is definitely this: if two triangles are similar, then they are called congruent triangles. Is it true, children? If two triangles are similar, can we say that they are congruent? Can you agree with this statement, children? Okay, I think you are not at all agreeing with this. It may be true or may not be true. If it is true, then only we call it as congruent triangles. If it is not true, we call them as just a similar triangles. Okay. So, it may be true or may not be true. So, this part I want you should understand this very carefully. So, if two triangles are congruent, then they will be similar triangles. If two triangles are similar triangles, they may be congruent or may not be congruent. Please keep this point in your mind. Okay. Thank you very much, children, for your patient hearing. So, with all my best wishes, I am T.K. Prasannamurthy, retired headmaster from Vijaya High School, Jayanagar, Bangalore 11.